Gang, I'm going to start demo number 2. I really don't need to go into a lot of explanation about what's up with the stuff, so with these demo videos, because I've explained that previously, so let's go for it. I'm going to make come at it a little different approach than you. I still want you to go over here to assignments like we did before, but I'm just going to go to preview and work it this way. It's just a little simpler on my end. So the following data set, we have 6 data points. So I'm going to open this in StatCrunch. And I can see I have a problem. The 3, which is the first data point, is actually the variable name, which is not cool. So I need to change that to, whatever data. And then I need to add the 3 down here. So it's kind of tricky. I don't like that. That's what happens. So we have to be, aware that that could happen. So now I'm going to go to stat, summary stats. I'm going to go to column. I'm going to choose data. And it looks like I need the mean and the median and the mode. So I compute that. The mean is 5. Get this over here. It says type an integer or decimal rounded to 4 places. I don't know what that means. That seems overkill, but okay, whatever. The median is 3.5. And the mode looks like there is one mode. Yeah, I'm just going to put 3 and see what happens. That should work. All right, the next thing we need to do is calculate the range, variance, standard deviation, and coefficient of variation. So I'm going to go up here and edit. I'm going to get rid of all this. So I need let's see, I need the variance, the standard deviation, the coefficient of variation, and the range. I think that's it. All right, so the range is 10. The variance is 13.6. The standard deviation is 3 points, so this is probably where we need to round to 3 places. So 3.688. And the coefficient of variation is 73 to 3 places, so we need to put 73.756. All right, next thing is compute the z-score. So from the previous video, we found out that the z-score is just the, and let me write it over here. Let me get rid of this temporarily. A z-score is just the value minus the mean divided by the standard deviation. So we know that the value needs to go right there. The mean we found to be 5.0. And the standard deviation we found to be 3.688. Now I'm going to show you how to actually calculate these. I think pretty easy. So if I just go to data and go to compute and go to an expression, I can build my expression. So what I want to do is I want to go left parentheses. And in here, I want to take the data minus the mean. And then I want to divide that by the standard deviation. And I want to hit OK. And I'm going to column label this as Z because it's a Z-score. And I'm going to compute that so I have the z-scores for my data. So for 3, I get, I want to round these to -3 places. So for 3, I get negative 0.542. For 4, I get negative 0.271. For 6, I get 0.271. Well, that was interesting. Did anybody notice that? Okay. Uh, for 3, negative 0.542. Oops. For 2, I get negative 0.813. One 1.898. Are there any outliers? Now, according to your textbook, outliers are defined by anything, any z-score greater than 3 or less than -3. A lot of textbooks will define it as -2 or below -2 or above +2. So what we're doing, we're looking at the z-scores and asking ourselves in the context of outliers, are there any above 3 or are there any below -3? And there are not, so we'll go for it. What is the shape of the data set? Well, we know that shape is defined by comparing the mean and the median. So when the mean is greater than the median, we know we have a positively skewed distribution. So by definition, positively skewed distribution.